What happens when a star dies? Does it simply fade away into the darkness of space? Or does it go out with the most violent, breathtaking explosion the universe has ever seen? Welcome to the story of supernovas, cosmic detonations so powerful they can outshine entire galaxies and forge the elements that make up you, me, and everything we know. This is the explosive truth behind the death and rebirth of stars. Let's start with the basics. A supernova is the dramatic death of a star, but not just any star. These explosions are the final, fatal act of massive stars, those with at least 8 times the mass of our Sun. But not all supernovas are created equal. There are 2 main types. A Type 1 supernova is usually caused by a white dwarf stealing too much mass from a companion star until it goes boom. And a Type 2 supernova occurs when a massive star runs out of fuel and collapses. Think of it like a cosmic pressure cooker. The star burns fuel, mainly hydrogen, fusing atoms together to release energy. This energy pushes outward, balancing the crushing force of gravity. But once the fuel runs out, gravity wins. In a fraction of a second, the star's core collapses in on itself. Temperatures soar to billions of degrees. Then, bang! An explosion tears through the star, ejecting material into space at thousands of kilometers per second. This is a supernova. Let's rewind. To understand how a supernova forms, we need to look at a star's life. Stars are born in clouds of gas and dust, called nebulae. Over millions of years, gravity pulls this material together into a dense ball. When the core gets hot enough, nuclear fusion ignites, and a star is born. For billions of years, the star fuses hydrogen into helium, releasing energy. But eventually it runs out of hydrogen. Heavier elements begin to fuse, helium into carbon, carbon into oxygen, and so on, until iron forms. Here's the twist. Iron doesn't produce energy when it fuses. Instead, it consumes energy. And when fusion stops, the core collapses. In less than a second, a star that's been burning for millions of years implodes. Then, the rebound. The outer layers smash into the collapsing core, creating an explosion so bright it can be seen from across galaxies. There are several types of supernova, but let's break down the big ones. Type 1a. These happen in binary systems, where 2 stars orbit each other. A white dwarf pulls matter from its companion until it reaches a tipping point and explodes. These explosions are incredibly uniform. So uniform, in fact, that scientists use them as standard candles to measure the size of the universe. Type 2, these are the core collapse supernovas we've been talking about, the death throes of massive stars. But there's more. Scientists have discovered variations. Type 1b and 1c are stripped-down versions of Type 2, where the star has lost its hydrogen or helium layers before the explosion. Each type tells us something about the star that exploded and the environment it died in. Here's something truly mind-blowing. Everything around you, your phone, your blood, the air you breathe, contains elements that were forged in the hearts of stars and released in supernova explosions. Stars are fusion factories, but it's the supernova that creates the really heavy stuff: gold, uranium, platinum. These elements didn't just appear, they were born in a cosmic blast. Carl Sagan once said, "We are made of star stuff." And it's literally true. When a supernova explodes, it seeds the universe with the raw materials for planets, moons, and life. Without supernovas, there would be no Earth, no oceans, no humans. Throughout human history, people have witnessed supernovas and recorded them. In the year 1054, Chinese astronomers documented a guest star that shone in the sky for weeks. It was a supernova, and today we call its remains the Crab Nebula. In 1604, Johannes Kepler observed another bright new star. This was the last supernova seen with the naked eye in our galaxy. These ancient observers didn't know they were watching the death of a star, but they knew it was something extraordinary. Today we use space telescopes like Hubble and Chandra to capture supernovas in stunning detail. Despite all we know, supernovas still hold mysteries. In 1987, a supernova called SN 1987A exploded in a nearby galaxy, the closest observed in over 400 years. It gave scientists a goldmine of data. More recently, we've detected superluminous supernovas, 10 to 100 times brighter than a typical explosion. Some even produce powerful gamma-ray bursts. And there's more. A rare type of explosion called a pair instability supernova might happen when extremely massive stars, over 100 times the Sun's mass, blow themselves completely apart. No remnant, no black hole, just gone. And then there are failed supernovas where a star collapses silently into a black hole. No explosion at all. We're still learning what stars are capable of. Supernovas aren't just fireworks for the cosmos. They're essential to how the universe works. Without them, galaxies wouldn't evolve, planets wouldn't form, life wouldn't exist, and scientifically, they're critical. Type 1a supernovas helped us discover dark energy, the mysterious force accelerating the expansion of the universe. They're cosmic beacons, chemical factories, and agents of change. They are destruction and creation, wrapped into one. Here's the million-dollar question. Could we see a supernova in our lifetime? Yes, and maybe even soon. There's a star called Betelgeuse, a red supergiant 640 light-years away. In 2019, it dimmed dramatically, sparking rumors of an imminent supernova. It hasn't exploded yet, but it will. Someday. When it does, it could shine as bright as the full moon, visible in daylight for weeks. Don't worry, it's too far to harm us. But it would be one of the most spectacular sky events in human history. From birth to death, stars shape the universe, and their final act is the most dramatic of all. Supernovas are not just endings, they are beginnings, forging the building blocks of life, lighting up the cosmos, and reminding us how small and how connected we truly are. The next time you look up at the night sky, remember, the atoms in your body were once part of a star that exploded billions of years ago. You are literally made of stars. Thanks for watching. Don't forget to like, subscribe, and stay curious.